This is problem 2 from the first midterm from the winter 2016 UW Math 120 pre-calculus course. This is a classic Collingwood question. We have a cake which is shaped as shown. All of these units are in inches. And we're imagining that we're going to cut this cake with some vertical cut. And our cut is going to be x units, x inches away from the left-hand side. So we might cut it 2 inches away from the left-hand side, something like here. We might cut it 8 inches from the left-hand side, something like here. And in each case, we're asked to, well, what we're asked to do is to find a multipart function, f of x, for the area to the left of the cut. So what this means is we want to write a function that, given any x, any spot to cut, we want to specify the area to the left. So you should notice that there's one kind of key spot where things get a little bit weird. We'll have one type of behavior if we end up cutting somewhere over here. And we'll have another type of behavior if we end up cutting somewhere over here. I know that my solution is going to be divided into 2 parts. The one where 0 is less than or equal to x is less than or equal to 6. And one where 6 is less than x is less than 10. And notice that I've chosen to include x equals 6. In this case, we should find a formula that will work when x equals 6 in both of these cases. But we, in general, want to just put 6 in one of these bounds or the other. So let's deal with the simpler case first. If we start with a cut that is part of this category, in other words, if we start with a cut that is to the left of here, so we're looking at something like this. And exactly how far over is this cut? Well, what I'm trying to do is express the area of this rectangle to the left here. The dimensions of this rectangle, well, the height of the rectangle is 8. And the width of this rectangle, well, what is the width of this rectangle? It's x. If I cut the rectangle x, if I cut the cake x inches away from the left-hand side, this rectangle has width x. So I can see that here, the area to the left of my cut will be simply 8x. So we've dealt with the cuts where x is less than 6. We've dealt with the cuts that are somewhere in this range over here. We need to deal with the cuts where x is greater than 6 but smaller than 10. So in other words, we need to deal with these cuts in here. So let's just draw one in. And let's say that we are working here, assuming that the distance from here to here is x. And let's see how we can express the area to the left here. You might find a variety of different ways to split this up into manageable shapes. One example might be to split this up into a rectangle and a quadrilateral here. One other example might be to say the area to the left of this cut is the area of the entire shape minus the area of this right-hand side. One other way might be to split this up into a rectangle here, if we draw a line like this, and a quadrilateral on top here. Either way, we're going to at some point need to deal with some triangular bit. And this triangular bit is a little tricky. So let's see what we can do. I think my preference for how to compute the area of this shape here would be to imagine that we finish off the rectangle. And then the area of this shape to the left is the area of the entire rectangle minus this triangle that we've kind of snipped off. So let's draw this in. What first is the area of the entire rectangle here? Well, the height of the rectangle is 8. And the width of the rectangle, we're assuming, is x. I'm not going to write that in, but this width from here to here is x, we're assuming. So I have that the area of the entire rectangle is 8x. And now I need to make sense of the area of this triangle here. Well, if the distance from here to here is x, and the distance from here to here was 6, then this remaining bit is certainly x minus 6. And the tricky bit is to deal with what this length is here. One option would be to give an explicit coordinate system to this and write an actual full equation for this line and solve for the coordinates of this point. Another option would be to just kind of make sense of the fact that, well, let's see, when x, from here to here, we have an increase in x of 4 and a change in y, a decrease in y of 6. So we could reason through that and say, okay, well, if I only have a change of x minus 6, what is the associated change in y here? Another really quite direct way to do this would be to draw a rectangle around. And notice that this triangle here that we're interested in is similar to the entire triangle as a whole. So we can write a proportion to compare the sides in question. We're interested in this one, which made me I'll label h. And it looks like what I can say is that this smaller rectangle, or smaller triangle, I can think of as having a ratio of side lengths of x minus 6 over h. And this larger rectangle, or larger triangle, sorry, I can think of as having dimensions, well, here to here is 4. And here to here is 6. So from here, I can solve for h. I can say that I find that h is equal to, I suppose it's 6x minus 6 over 4. So now if I know this length and this length, I can express the area of the triangle. I can say that the area of the triangle is equal to 1/2 the base times the height, 1/2 of h, 1/2 of h, 1/2 of h times x minus 6. So what I'm interested in was expressing the area to the left of this cut. The area to the left of this cut was the area of the rectangle, which was 8x, minus the area of this triangle, which for here I'll abbreviate to just a sub t. In an exam context, I would certainly write out 8x minus and then all this mess kind of stuck in there. But there's no real need to simplify this any further. This is a perfectly reasonable expression for the area to the left of the cut for any x between 0 and 10.